be discussing about the DSO and CRO in depth. First of all, we'll talk about the Digital Storage Oscilloscope, which is known as a DSO. So the DSO is one type of oscilloscope used to display the waveform, but the difference between DSO and CRO is that in DSO, the digital signal is converted into analog, and that analog signal will be displayed on the screen of the digital storage oscilloscope. In the conventional CRO, there is no procedure for the storage of the waveform, but in DSO, there is a digital memory that is going to store the digital copy of the waveform. Now, I'll give a brief description about the DSO. So, what is the digital storage oscilloscope? The digital storage oscilloscope, known as a DSO, is an instrument which gives the storage of a digital waveform or the digital copy of the waveform. It allows us to store the signal of the waveform in the digital format and in the digital memory. Also, it allows us to do the digital signal processing techniques over that signal. The maximum frequency measured on the DSO depends upon the two things there. First of all, the sampling rate of the scope, and secondly, the nature of the converter. Now, if we talk about the block diagram of the DSO, at first a digital storage oscilloscope digitalizes the analog input signal, and then the analog input signal is amplified by the amplifier if it has any weak signal. Now, after amplification, the signal is digitized by the digitizer and digitized signal stores in the memory. The analyzer circuit processes the digital signal. After that, the waveform is reconstructed. The cathode ray tube has two inputs. They are vertical input and horizontal input. The vertical input signal is the y-axis and the horizontal input signal is the x-axis. The time-based circuit is triggered by the trigger and clock input signal. So it is going to generate the time-based signal, which is a ramp signal. Then the ramp signal is amplified by the horizontal amplifier, and this horizontal amplifier will provide input to the horizontal plate. When the analog signal is properly converted into digital, then the resolution of the analog to digital converter will be decreased. When the input signal stored in analog store registers can be read out at a much slower rate by the AD converter, then the digital output of the AD converter stored in the digital store, and it allows operation up to 100 megasamples per second. This is the working principle of a digital storage oscilloscope. Now, we'll talk about the cathode ray oscilloscope, which is a CRO. So, the cathode ray oscilloscope is the type of electrical instrument which is used for showing the measurement and analysis of waveforms and other electronic and electrical phenomena. It is a very fast XY plotter, shows the input signal versus another signal or versus time. The CROs are used to analyze the waveforms, transient, phenomena and other time varying quantities from a very low frequency range to the radio frequencies. The CRO is mainly operated on voltages, thus other physical quantity like current, strain, acceleration, pressure are converted into the voltage with the help of a transducer and thus represent on a CRO. It is also used for knowing the waveforms, transient phenomena and other time varying quantity from a very low frequency range to the radio frequencies. The horizontal voltage moves the luminous spot periodically in a horizontal direction from left to right under the display area or screen. The vertical voltage is the voltage under investigation. The vertical voltage moves the luminous spot up and down on the screen. When the input voltage moves very fast on the screen, the display on the screen appears stationary. Thus, CRO provides a means of the visualizing time varying voltage. The CRO has a stylus which moves over the display area in response to an input voltage. The luminous spot is produced by a beam of electrons striking on a fluorescent screen. The normal form of the CRO uses a horizontal input voltage, which is an internally generated ramp voltage called time base. Now, the construction of cathode ray oscilloscope is as follows. First of all, it consists of a cathode ray tube, then an electron gun assembly, then a deflecting plate, then a fluorescent screen for CRT, and then a glass envelope. First of all, I'll talk about the cathode ray tube. The cathode ray tube is a vacuum tube which converts the electrical signal into the visual signal. The cathode ray tube mainly consists of the electron gun and the electrostatic deflection plates. The electron gun produces a focused beam of electron which is accelerated to high frequency. The vertical deflection plate moves the beams up and down, and the horizontal beam moves the electrons beams left to right. These movements are independent to each other and hence beam may be positioned anywhere on the screen. Now we'll talk about the electronic gun assembly. The electronic gun emits the electrons and forms them into a beam. The electron gun mainly consists of a heater, cathode, a grid, a pre-accelerating anode, a focusing anode, and an accelerating anode. For gaining the high emission of electrons at the moderate temperature, the layers of barium and strontium are deposited on the end of the cathode. After the emission of an electron from the cathode grid, it passes through the control grid. The control grid is usually a nickel cylinder with a centrally located coaxial with the CRT axis. It controls the intensity of the emitted electron from the cathode. The electron, while passing through the control grid, is accelerated by a high positive potential which is applied to the pre-accelerating or accelerating nodes. The electron beam is focused on focusing electrodes and then passes through the vertical and horizontal deflection plates and then goes on to the fluorescent lamp. The pre-accelerating and accelerating node are connected to 1500 volt and the focusing electrode is connected to 500 volt. There are two methods of focusing on the electron beam. These methods are electrostatic focusing and electromagnetic focusing. The CRO uses an electrostatic focusing tube. Okay, now we'll talk about the next part, which is fluorescent screen for CRT. The front of the cathode ray tube is called the faceplate. It is flat for screen sized up to about 100 mm cross 100 mm. The screen of the CRT is slightly curved for larger display. The inside surface of the faceplate is coated with phosphor crystal. The phosphor converts electrical energy into light energy. When an electronic beam strikes the phosphor crystal, it raises their energy level and hence light is emitted during phosphorus crystallization. This phenomena is called fluorescence. Then fifth is the glass envelope. It is a highly evacuated conical shaped structure. The inner surface of the CRT between the neck and the screen is coated with the aqueduct. The aqueduct is a conducting material and acts as a high voltage electrode. The coating surface is electrically connected to the accelerating anode and hence helps the electrons to be the focus. Now we'll discuss the working of the CRO. Now when electron is injected through the electron gun, it passes through the control grid. The control grid controls the intensity of the electron in the vacuum tube. If the control grid has a high negative potential, then it allows only a few electrons to pass through it. Thus the dim spot is produced on the lightning screen. If the negative potential on the control grid is low, then the bright spot is produced. Hence, the intensity of light depends upon the negative potential of the control grid. After moving the control grid, the electron beam passing through the focusing and accelerating nodes. The accelerating nodes are at a high positive potential and hence they converge the beam at a point on the screen. After moving from the accelerating anode, the beam comes under the effect of the deflecting plates. When the deflecting plate is at zero potential, the beam produces a spot at the center. If the voltage is applied to the vertical deflecting plate, the electron beam focuses at the upward, and when voltage is applied horizontally, the spot of the light will be deflected horizontally. This was all about CRO. Now we'll get into what the slides are showing. Here I have mentioned the difference between the DSO or the CROs. So first of all, if you talk about resolution, then the DSOs have a higher resolution as compared to the CROs and can capture more data with increased accuracy. Now if you talk about bandwidth, the DSOs have a higher bandwidth as compared to the CROs, which means they can capture signals up to much higher frequencies. Now, if we talk about the oscilloscope probes, we have a voltage probe, we have a current probe and differential probes. Voltage probes measure difference in potential between the 2 points and are used for voltage measurements. And then if we talk about the oscilloscope triggers, we have edge triggering, which is the most commonly used. We have then pulse width triggering, logical triggering and video triggering as well. Okay. Now, if we talk about what we conclude from this statement is that DSOs and CROs both are very powerful in their own ways. DSOs and CROs can be used at the same time and they can be used like in synchronization with each other. Then we'll talk about the Lissajous pattern. The Lissajous pattern is a complex and beautiful graphical representation of the relationship between two sine waves. It is commonly used in physics, engineering, and mathematics to study phase relationships and harmonic motion. By analyzing the shape and frequency of the pattern, valuable insights can be gained about the nature of the two input signals. Now, if we talk about more about the Lissajous pattern, I have attached a video which shows certain Lissajous patterns which we have obtained in the lab. Yeah. So that's it from my side, and thank you. Yeah, that's it. Bye bye.
We have set the frequency as 1 kHz in this function generator, and in the second function generator too, we have set the same frequency. As a result, we are getting a circle as the output.